On this team, we tear ourselves and everyone else around us to pieces for that inch. Yeah. We claw with our fingernails for that inch. That's gonna make the fucking difference between winning and losing. I'll tell you this, in any fight, it's the guy who's willing to die who's gonna win that inch. There's 6 inches in front of your face. Now, what are you gonna do?
Alright, and welcome to another episode of Basketball Analytics. In my last video, we covered anthropology, so given your body type, finding your ideal position. In today's video, we're going to talk about number 2, physical performance. I've scraped data from the 2000 to 2019 NBA Draft Combine with over 1,300 players, looking at bench, standing leap, max leap, lane agility, modified lane agility, and three-quarter sprint. In my last video, we did an anthropological matchup between Max and Steph Curry, and we found that they were very similar, so we're going to aim to train Max for a point guard / shooting guard position. If we look at the top point guards in the league right now, given points scored, we have James Harden, Stephen Curry, Damian Lillard, Kemba Walker, and Kyrie Irving. Right here are their NBA Draft Combine numbers. At the top, we have player anthropology, so height with no shoes, weight, wingspan, standing reach, body fat, hand length, and hand width. At the bottom here, this is what we're most interested in, physical performance. So we have standing leap, max leap, lane agility, modified lane agility, three-quarter sprint, and bench press. So these are the metrics for Max's ideal position. However, I would love for you guys to pause the video right here, look at what your ideal position is, what the range needs to be for each given metric and your ideal position. And I have them all up on the screen right here. Next, what we need to do is benchmark Max's metrics. So if we take an average of all of these metrics given these 6 players, for standing leap, we have 32.2 inches. For max vertical leap, we have 38.6 inches. For lane agility, we have 10.92 seconds. For modified lane agility, we have 2.8. Three-quarter sprint, we have 3.22. And bench press, we have 12 reps. Alright, so that covers physical performance, the metrics that Max needs to get to in order to gain those inches and increase his odds of playing at a high level. So far, we did videos on anthropology and physical performance. However, I look forward to going over the next 3 with you in future videos. The second part of this video will be a technical deep dive into the data pipeline that I built in order to gather all of this data and visualize it for you guys. If you're interested in learning how I did this, please stay tuned for part 2. If not, I look forward to seeing you in the next videos. Thank you very much and see you soon. Bye-bye. Alright guys, welcome to part 2. This is a technical deep dive into my data pipeline. So I'm going to show you how I extracted the data and how I visualize it using Amazon Web Services. Okay, so I've prepared all of the code in advance, and so we're going to do a live demo today where I run each block, and I'm going to show you in my AWS console what exactly is going on. Right here in my Jupyter notebook, I have a little schematic of what we're going to do, and it's an easy 5-step process. So the first step is really a housekeeping step. You need to set up an IAM user, so make sure that you can locally access your AWS services. Next, you're going to want to create a Redshift to S3 role, so this gives Redshift the right to read S3 files. After that, you're going to want to create a security group that you attach to your Redshift cluster, and you're going to want to open the TCP port, and I'm going to show you that in my AWS console. And once that's done, you can get to the fun stuff. So I did all of my extraction and transformation locally. And then I go back and forth with S3 to put the data onto S3. And next I do some transformations. And once I have my data ready and in a form that Redshift can understand, I use that data to copy over to Redshift. And I'm going to show you that as well. And finally, once that's done, you can easily connect your data within Redshift to Quicksight, which is AWS's visualization tool. So let's get started. I'm not going to concentrate too much on the actual code. I want to give a good overview and show you the essential parts. And if there are parts you'd like me to go deeper into, I definitely do another video on. So here are the packages that are most important. So I'm using an open source package that you can find on GitHub called NBA Pi. And here you can extract data off the NBA website. You can get data from the draft combine like we're doing today. Next you have pandas, so data frame stuff. And this is another package that I really like. So with this Jupyter notebook and with my processes here, I'm actually not storing anything locally. So I'm using this S3FS package to actually do the transformations on my computer using data frames, but then I put it directly onto S3. So I'm not storing the data locally, which is really cool. And then all of these other packages are pretty standard. I have a constants file, which I'll explain later as well. And then we use this PSY package here in order to do SQL queries to our Redshift cluster, and then Boto3 to access AWS's services via Python in my Jupyter notebook. Alright, so let's get started. So I'm not going to bore you with the details, but these first 4 blocks are essentially just transforming the data into a way that I can do computations on and that I can put it into a way that Redshift can understand. So let's just skip these 4. Alright, so now we're at the main ETL block. So these first lines here are just importing my constants columns list. So the reason why I have to do this is because they started recording in 2000. However, the stats that they record now and compared to 2000 are actually a little bit different. They include some more stats on shooting and stuff like that. So in order to create one data frame that's uniform and that I can do analysis on, I have to kind of fill in the gaps for the column values that were not in existent before. So I think from 2011 to 2019 are pretty similar, but everything before that is a different. So I had to do that there. And then here I just import the seasons. So I'm trying to scrape all the data from 2000 to 2019, like I said, and this one is really important. So I set the path root file. So this is what I'm going to name my bucket in S3. I'm doing everything live, so you'll see another bucket in my S3 bucket that's actually called NBA Draft Combine Data Demo, but I'm adding a live here, so we're going to do it right now. And then all of these other paths are actually paths that I dump the data into in between processes. Let's quickly comment this out. And then we're going to make a bucket within S3 that has this path root name. So let's run this. All right, no errors. So let's go to my S3 bucket and check if it's actually there. All right, so this is my S3 bucket, and we just organize this by date created. All right, here we go. We just made this one. And if we open this up, we'll see that there's nothing in there. All right, nothing in there. So now I'm going to run the 4 transforming processes in order to put my data into S3. So let's do that now. So that's this block right here. So essentially the first step is to scrape the data. Then I have to make data frames that have all of the same column names. And then I have to fill in the values that are null or NaN. And then what I actually have to do is create a unique ID. Because I found when I was looking at the data, there were actually, I think it was less than 50 players there, but there were quite a lot of players who had actually participated twice in the NBA draft, and so their actual player ID is not unique. And so what I did was I created a player ID concatenated with the year, so the year that they participated in, to create a unique ID. And so that's this last step. And I removed the headers and I filter out the columns that I need for this video in the last step here. And this last step will give me the data that Redshift knows how to read. So let's run this now. All right, so it's running. We can see that it's getting all of the data. It's at 2013 right now. It's still on the first step. All right, cool. So it looks like the first step is done, and now it's doing the next step. All right, while that's running, let's go over to S3 and see how the bucket looks like. All right, so like before, we had nothing in this bucket, but let's just do a quick refresh to see what's going on. All right, so it's refreshing here. So remember how I said that there were 4 steps? So the first step was actually getting the raw data. See that in here. And then if we go back, this is the data with all the columns fixed. And then looks like it's on the 3rd process. So this is the data with all the values in the columns fixed. And then we'll wait till the 4th one's done. So let's go back to the Jupyter notebook and see where it is. So I printed out some of the processes that's going on here. So something that I found that was weird was on some of the data columns, they have, instead of having percentages, they had this 0/0 thing. So, and which was weird, or they had this 3/4. So what they're actually trying to say is that the player made 3 out of 4 shots, but because it's a string and it's weird, Python doesn't really understand it, so I had to create a script that actually cleans for this, and so that's what this is doing right now. Yeah, see here it's converting them all to percentages, which is good, and we should be done soon. So what I love about this notebook is that you can use it on other data sets, and so I'll definitely be using this in other demos and other projects. Jupyter is a great way to troubleshoot and try out things when you're first learning. Okay, so it looks like it's done adding the IDs, and so now it's doing the last step where it's putting the data in a format that Redshift can understand. Okay, now let's go check out my S3 bucket and see how it's doing. Alright, so it looks like it's done. As you can see, I concatenated each process on top, so it has the same name, but I put the process step for every time it's completed something. So let's go back to the notebook. Alright, so now that that's done, we can load our data into Redshift. So let me show you that here. Alright, so before we can load our data into Redshift, we have to initialize some parameters. We have to get our access and secret key of the user so we can access services on AWS. And then next we have to set out our cluster parameters. And let's just run this again. So here we have all our parameters and the values. Next we have to call the Redshift client, create a rule that gives Redshift read-only access to S3. All right, this is a big one. So now let's create the cluster. No errors. That's a good thing. And then next, okay, so this one calls the cluster we created in Redshift, and let's do that here. All right, so you can see we made a Redshift cluster with an identifier called NBA Draft Combine. We can see the node type, etc., etc. And right here, something important, so it's creating. So we can't go any further until this is done creating. So you can keep running this until it's done creating, still creating. But what I want to do is I want to go to my AWS console and show you guys that Redshift is actually, and show you guys that a Redshift cluster is actually spinning up. All right, so let's go let's switch back. Right, so this is my console prior to spinning that out. Let's reload. And go to clusters. So cool. Now we've got an NBA Draft Combine cluster spinning up. It's creating, everything looks good. Okay, so I really like infrastructure as code because as you can see, you can just code it in anywhere and run it, and it will interact with the services in AWS, and you're pretty much autonomous. So this is something I really like. And so I'd like to transform this notebook to be more automated. Alright, so now we're back in our Jupyter notebook. Let's rerun this code block and see if it changes from creating to finished. It's available. Okay, now we're ready to go. Alright, and so you can see all of these things right here. You can see our endpoint. And so in my next block here, I'm actually assigning the endpoint address and the database name and the ports to some variables here so that we can connect to our Redshift cluster from our Jupyter notebook. So let's do that right now. Connected. Boom! Connected. Okay. Man, I always get so happy when I run something and it works. Okay. So this next code block actually creates the table. So this first one, it drop if it exists and create it if it does not exist. So let's run that here. Boom, done. Boom, boom, boom. You can tell that I did a lot of work before this because everything is working. And usually when you do a live demo, nothing works. Okay, so the tables are done creating. Actually, let's go to our AWS console and actually look at the tables. Okay, so let's go out of there. All right, so we're here, and so in your Redshift console here, you can go to Query Editor, and here I only have one cluster, so it knows it's the NBA Draft Combine one, and so if you just let's do that here. Warehouse user. Okay. When we connect, we can actually do some SQL queries from the console. Alright, so we go to this schema here and we go to our public schema right here, and we can click on this eye and actually see there are no results yet. We haven't copied the table over. But yeah, so you can go to the query editor and do some SQL queries. Oh, and one really good thing I recommend is when I was doing some troubleshooting, I was trying to figure out why my tables weren't copying over correctly, and something that you can use for troubleshooting is actually here. So you go back into the schema. I might get this wrong, but I think it's in the internal, no, not internal, the catalog, and then you do, and then what you want to do is, it's called error. There you go. Here we go. So you go to this one, STL load errors, and you can click there, and you can see all of the errors for your queries. So why a table doesn't get copied over, any it's so finicky. If you have some syntax error or something that shouldn't belong in the data, it won't copy over. And in your Jupyter notebook console, you won't even really see why there's an error. It will tell you to go look at this STL load errors thing. So now you know where to go. So you go in your query editor, or you can do this from the Jupyter console as well. But if you want to do it on AWS, go to Query Editor, go to your schema, go to this PG catalog thing, and then you go and you load this STL load errors. And you can see all your errors. This definitely helped me when I was troubleshooting. Alright, so we spun up our Redshift cluster, we created a table. Now we're almost at the end. All we have to do is copy the finalized process data into our table that we created in Redshift. So let's do that now. All right, so we're back here. Okay, this is my favorite part. I want to run this and I want it to work the first time. Let's do this. Did I not run something here? Boom, 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 it's done. Yeah. Boom, 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 boom. Yeah. Oh man. It worked. Okay. Alright, so now we're done. The data is in Redshift. Now we can visualize. It's so cool. Okay. Alright, let's go back to our AWS console and go into Quicksight, and I'm going to show you quickly how you can get this set up. For some reason, whenever I go into Quicksight, it automatically connects me to North Virginia. Let's go into US West 2. Okay, I've already created the dashboard, but I'm going to quickly show you how you can connect it up. So you go up here to the top right, you go to Manage Data, you go to New Data Set, and then you go here, Redshift Auto Discover. And I only have one cluster up, so it's going to know what it is. Let's name this NBA Draft Combine. Boom, boom, boom. And here we put in our username and password and create data source. Yeah, click the table. Yes, and we're working. Visualized. Oh. Alright, so I'm gonna quickly make a quick one right here. Just go here, you can go, got tons of data in here. Go to position, put that on the Y. Let's go to height, because we know we already looked at this. Alright, and boom, 100% successful. 1,350 rows. Alright, and we don't want to do sum, we want to do average. Boom! So we already covered this in my last video, but this looks better than the graph that I had in my last video. So we've got position here, and we've got their height, average height, without shoes. Alright, so I'm going to go back to the start of Quicksight, and I'm going to go to the graphs that I've already made. This one. Alright, so let's go to top here, maximize. Boom. So my first graph here, the first thing I asked myself, okay, I have 1,350 participants. Okay, who are these participants and what positions do they play? Alright, so here we have power forward with 234. You can keep going, shooting guard, power forwards, etc., etc. So I think this graph is super cool. Shows you what positions and who's trying out for what. And so a question you might have is, why is there point guard, shooting guard? And then if you go search somewhere else, you should see shooting guard, point guard. Here, shooting guard, point guard. So I think the way it works is that you have the person's primary position first, so point guard, and then their secondary position, shooting guard. And so if you put these two together, there's 100 of kind of the same people. But yeah, power forwards, there are a lot of power forwards that try out for the NBA draft combine. And so yeah, and so strength. Maximize. All right, so here's the average bench press reps per position, and obviously center power forwards have the higher averages, and then yeah, you keep going, you can look at all the positions, and then lane agility, maximize this, same type of thing. Got modified agility. And obviously your shooting guards, and yeah, you got modified agility. Okay, max leap. So this is the one that people are usually always interested in. And so you have the average max vertical leap. So this is the one where you can run and you can actually try and hit the bars. Up here, average is 34 inches, and then standing leap. So this one's similar to the max leap. However, you have to be standing. You can't be running. And then body fat. So this is a cool one. Yeah, centers usually have the higher body fat, and then your point guards and shooter guards stay pretty lean. I guess that's how they stay real quick. And then another one that I was interested in is does the strength of the players change throughout the seasons? So right here I have a bar graph of each position grouped by the actual season. So I was doing a lot of comparisons with Max's position. So it's a point guard, shooting guard. So if we just go to that one. Okay, so we just go to that one and we hover over it, and then we say focus only. Oh no, we want point guard, shooting guard. Yeah, focus only on point guard, shooting guard. All right, so 2019, 18, 17, not so strong. And then 13, pretty strong, 13 reps. And then 2011, those guys were the strongest pack, so 15. It would be cool to go back and see who was actually in the 2011, 2012 draft and see who had the highest scores here. Yeah. So it looks like if you take the average over time, it doesn't really change. You have some years where there are some averages that are higher, but they actually kind of stay the same. I wish I had more data from like the 1980s to now, because if you look at a basketball player's body type right now compared to before, they're actually quite different. So it would be cool to do this comparison, but there isn't data before 2000 readily available. All right, so that's Quicksight, really cool. You can easily connect your data here and do some visualizations on it. Right, so let's go back to our Jupyter notebook. All right, so that was my whole process. I showed you how I extracted, how I transformed, how I put that data into S3, and then how I copied that data into a table in Redshift, and then how I visualized it in Quicksight. And so some improvements I'd like to make to it. I like to be more infrastructure as code, so I'd like to automate more of the process so I don't have to keep checking in the AWS console. I like to develop a better star schema. So as you can see there, it's super simple. It's just one table. But you can imagine, even just by my other video that I did on anthropology, I can create more tables around different types of information and then connect them together. So I definitely need to make a better star schema. Next, I actually want to transfer my extracting and my loading onto the cloud on maybe an EC2 instance, running on a cron schedule, so I don't actually have to tie up my computer when I'm doing computations. I can just do it all in the cloud. And then lastly, it would be good to implement either maybe Apache Airflow or AWS data pipelines to even automate it even more and be able to monitor the process better, and maybe get notifications to my phone using the SNS service. But anyways, that's it. And so I'd like to give a special thank you to Amazon Web Services for giving me the idea for this video and for the sponsorship of this video. And then I'd also like to thank Udacity, Udemy, YouTube, and Google for teaching me everything I know. We've never lived in a better time to learn. And last but not least, I'd like to thank the open source community. I'm using a lot of their packages in this Jupyter notebook and throughout all my projects, and I want to thank them for helping me accelerate my learning. So if you like this video and you found it interesting or even learned something new, please like and subscribe below, so it helps me understand what type of videos I should be making for you. And I look forward to doing the other 3 topics on my 5 steps to increasing your odds to getting to the NBA or playing at a high level. So stay tuned. Bye-bye. Boom! Refresh aí.